Okay, so we're going to start today with talking about increasing and decreasing intervals of a function. And really, we're just going to be doing that by looking at a graph. You're not going to be able to answer these types of questions but just by looking at an equation until you get to calculus. But understanding what those are and what exactly you're looking for is important, though. So let's say we've got a graph here of a function. Let's say it's doing something kind of like this. And this is at, let's say, 1. This is at 5. That's 7. -4. And maybe -6. Okay. So increasing and decreasing. You have to think about like a little point that's moving along the curve of the function, and it's going left to right. Okay? So whenever the little point is moving up on its journey, it's increasing, and anytime it's moving down on its journey, it's decreasing. Okay? So to be able to identify increasing and decreasing intervals, I have to know where the maximum and minimum points are too. So this is kind of related to that extrema thing we talked about. Okay? So I'm going to mark where those are at. So right here is a minimum. Up here is a max. And that point there is a min. Okay, so based on that, can we identify intervals where this thing is increasing or decreasing? And the intervals we want to describe are x values. So from what x value to what x value is it increasing? Or from what x value to what x value is it decreasing? Okay, so can anybody give me an increasing or decreasing interval that you see on there?
From -6 to 1 is increasing?
Yeah, good. So we have an increasing interval from -6 to 1. Okay, now there's some debate. You could write it this way with parentheses, or if you wanted to actually include the -6 and the 1 as part of the increasing interval, I guess technically that's true. Okay, so I'm going to accept it either way, the parenthesis or the bracket. In this case, it doesn't really make a difference. Okay, but that's correct, though. That's an increasing interval. So can somebody else give me another increasing/decreasing interval that you see in the picture there? From where to where?
Decreases from 1 to 7.
Okay, decreases from 1 to 7. And again, you could do it with the brackets if you wanted. Okay. And there are 2 more intervals on there still that we haven't done anything with yet. Anybody see where those are at? Yeah, go ahead.
Increasing from 7 to infinity.
Yeah, good. Yep, from 7 to infinity it increases again. Okay, or again, could do it with a bracket. Just remember the infinity, though, it's never going to have a bracket, though, so can't do that. And then there's one more interval that we haven't described yet. Is it increasing or decreasing? It's decreasing from -infinity to -6. Yep. Or again, if you wanted to use the brackets, you could do that. Okay, so good. So like I said, the key is to identify where those maximum and minimum points are, and then using that to set up where is it increasing, where is it decreasing. As long as you think about that, going from left to right, where's it going down, where's it going up, then you got it. Okay. You don't need to worry about y values with this. It's all x. Okay, from what x to what x, and you can do it. Now we can do this on our calculators as well, and I'm going to kind of wrap this into doing it with finding extreme values. Okay, so let's graph a function here real quick. Please do. And we'll do one that's fairly simple here. We'll just have like one increasing interval and one decreasing. Okay, so I'd like you to graph that function for me. X squared plus 2x plus 1. We're going to just do a parabola. All right, and if we go ahead and use a window, standard window, should be able to see it. Okay, so negative 10, 10, negative 10, 10. And graph's going to look like that. Okay, so I want to know, where is this parabola increasing, where is this parabola decreasing? Okay, so to do that, again, I got to identify where the maximum and or minimums are on the graph. So in this particular graph, we have maximums, minimums. What's going on? What do you see? There's a min. It's just one, right? So we got to identify where that minimum is, and the calculator can do that for us. Okay? So if we go second calc, and we can do a maximum or a minimum right here in that same menu where we did the zeros before. Okay? So if we go minimum, it's going to want a left bound and a right bound again. So you're going to move the little cursor along your graph to the left of where you think the minimum is, hit enter, and then it wants a right bound. So you go to the right of where you think the minimum is, hit enter, and then it's going to do a check in between. And the calculator says negative 0.9999999. What is it actually? Negative 1. Yeah. Again, it's doing this weird not quite getting there thing that it sometimes does. And I don't know if some of your calculators, if the newer models like got negative 1 or not, but
Mine's worse. Mine for the y value has 4.28 exponent to the negative 12 for the y value.
So it's not even giving you a 0 for the y. Okay. Yeah. So sometimes you have to kind of outthink the calculator a little bit, know what it's really trying to tell you. Okay. So this is, the minimum is at negative 1, 0. Okay. So if I want to know what's the decreasing interval for this, what would be my answer then? Negative infinity to negative 1. Remember, we're just doing the x value. Good. And what's the increasing interval? Negative 1 to infinity. Okay? So you can use the calculator to do that, but you have to use it to pinpoint the mins and the maxes first, and then you can start using that to piece it all together, just the same as we did before. So, okay. So that's that increasing and decreasing stuff. Extrema, kind of already did it. I'm just going to put in parentheses here maxes and mins, because that's really what you're doing. And again, if I give you a graph, can you do it? Also, if you have a calculator, can you type it in and find the maxes and mins as well? Now, just one thing that we probably need to discuss here a little bit with this is this idea of a relative max and min, okay, versus a absolute max or min. So I'm going to try and draw a function here where we've got all of this going on. Okay, so let's say we got that. This function has two relative maximums and two relative minimums, but it has one absolute max and one absolute min. Okay? And in fact, if I'm going to be real technical here, which I should be, these aren't going to be arrowheads. That's going to stop, and this is going to stop. Otherwise, it wouldn't have absolutes. Okay, so do you guys kind of get what I'm getting at there with that? Two relative maxes, two relative mins, but only one absolute and one absolute for the min and the max. So, this point right here, which of them is that? That's a relative maximum. Mm-hmm. So by relative, it means compared to what's around it. Okay? What's in the neighborhood, that sort of thing. Okay? What's close to it. That's a relative max. Now this maximum over here is an absolute maximum. It's also a relative max because it is the biggest thing around. Okay? But it is also the highest point of the entire function. Okay? So this one is an absolute max. But I'll put in parentheses also relative. Okay, and then with the minimums, same kind of thing, right? This is going to be a relative min. And this one over here will be the absolute min. But it is also relative. Okay, not every function, though, is going to have a relative max or min or an absolute max or min. Okay, it just kind of depends. I happen to draw a function that I knew would have examples of all four of those things going on. All right, so I'm going to give you another one, and I want you to see if you can identify relative / absolute maxes and mins, but only give me the ones that exist. Okay, if it doesn't have a certain kind, then you don't need to list it.